Over the past few months, the attention of the world's leading analytical centers has increasingly shifted from the traditional arms race to a far more ambitious arena, the struggle for Earth's orbit. And while just a few years ago, such discussions seemed more like futuristic science fiction scenarios, today an increasing number of authoritative publications, including Space.com, Reuters, and several confidential analytical reports, indicate that China has begun implementing one of the most ambitious space projects in human history. This is not merely about expanding an orbital space station, but about the gradual creation of a fully operational orbital base that could eventually become the primary transportation hub for interplanetary missions. According to sources close to China's space program, Beijing views Earth's orbit as a strategic resource comparable in importance to maritime trade routes or energy corridors. Whereas space was once regarded primarily as a scientific domain, it is now becoming an integral part of geopolitical strategy. China is not simply entering space, it is establishing a permanent presence there by building infrastructure that could provide it with a significant strategic advantage in the future. The starting point of this project was the Tiangong Orbital Space Station, which is already operating as a permanently crewed facility. However, according to insiders, this represents only the first phase. Chinese engineers are already working on expanding the station to 6 modules, effectively doubling its size and capabilities. This means more laboratories, larger crews, more scientific experiments, and, perhaps most importantly, greater capacity to service other space assets directly in orbit. But the next stage is even more intriguing. According to information leaked from Chinese scientific circles, discussions are underway regarding the creation of a modular orbital infrastructure capable of functioning as a true space hub. Imagine not merely a space station, but an entire complex capable of accommodating various spacecraft through docking, cargo vehicles, research modules, orbital telescopes, and even prototypes of interplanetary transportation systems. And this is where the key concept increasingly discussed in the Western media emerges. China could become the first country to establish a fully operational orbital assembly point for spacecraft. This would fundamentally change the rules of the game. Instead of launching enormous and extremely expensive spacecraft directly from Earth, they could be assembled in space from individual modules delivered separately into orbit. This approach would be more economical, more efficient, and would open entirely new possibilities for deep space missions. According to Reuters, Chinese authorities already view this orbital base as the future launch point for lunar and Martian missions. The reasoning is straightforward. Launching from orbit requires significantly less energy than launching from Earth's surface. This means spacecraft could carry more fuel, more equipment, and potentially even larger crews. At the same time, China is rapidly developing its transportation infrastructure. The new crewed spacecraft known as Mengzhou is designed to carry larger crews on longer duration missions. Simultaneously, new cargo systems are being developed that will be capable of regularly delivering modules, equipment, and resources into orbit. Altogether, these developments appear to be preparations for something far greater than a conventional scientific space station. Another interesting aspect is that alongside these developments, China is also advancing the Suntian Orbital Telescope, which is designed to operate in conjunction with the station. It will periodically dock with the station for servicing and upgrades, making it an integral part of the broader infrastructure. These are no longer isolated projects, they are components of a single integrated system. That is why some analysts have begun using the term orbital ecosystem. This means China is not simply building a space station, it is creating a network of interconnected assets that together form a resilient and sustainable space infrastructure. At the same time, experts are increasingly using a stronger expression, orbital dominance. According to a number of American analysts, China is effectively attempting to secure the most important positions in low Earth orbit before other nations do. Whereas such concerns were once focused primarily on military satellites, the discussion has now expanded to encompass an entire orbital infrastructure. Some sources claim that Beijing is considering the construction of orbital shipyards where spacecraft could not only be assembled but also serviced. This could include satellite repairs, equipment upgrades, and even the recycling of materials directly in space. If such capabilities are successfully developed, China would gain an enormous strategic advantage. Against this backdrop, the approaching end of the International Space Station's operational life takes on particular significance. If the ISS is retired within the next few years, China could become the only nation with a fully operational orbital base. That would automatically position it as the primary destination for international space projects. China is already actively inviting other countries to participate in scientific experiments aboard its space station. This is not merely scientific cooperation, it is also an exercise in soft power designed to strengthen influence and attract long-term partners. However, behind all of this scientific rhetoric lies a more pragmatic calculation. Control over orbital infrastructure ultimately means control over access to space, and that represents a strategic advantage whose importance is difficult to overstate. Some insiders suggest that, over the long term, China could build a multi-layered space infrastructure extending beyond low Earth orbit to include the cislunar region. This is directly connected to the International Lunar Research Station project, which China plans to develop with its partners during the 2030s. When all of these elements are considered together, the orbital station, transportation spacecraft, space telescopes, potential orbital shipyards, and future lunar missions, it becomes clear that this is not an isolated project, but an overarching strategy. It is a strategy aimed at gradually expanding China's presence in space and, to some extent, securing key strategic positions beyond Earth. That is why one question is being raised more frequently than ever. Is Earth's orbit becoming the next arena of geopolitical competition? And if so, whichever nation succeeds first in building a sustainable orbital infrastructure could secure a strategic advantage lasting for decades. China, it appears, has already made its choice. It is not merely participating in the new space race. It is attempting to redefine its rules by shifting the focus from individual missions to the creation of a permanent presence in space. And if this strategy succeeds, the coming decades may witness the emergence of the first truly large-scale orbital base, serving not merely as a scientific outpost, but as the central hub for future interplanetary travel. At that point, space will finally cease to be merely a symbol of scientific progress. It will become a new domain where the future of technological and geopolitical leadership is determined. But if we look even deeper, it becomes clear that we are seeing only the tip of this project. Alongside the official announcements about scientific research and international cooperation, confidential analytical reports are increasingly discussing what is referred to as the second orbital phase. And it is precisely this phase that is causing the greatest concern among Western experts. The essence of this phase is the transition from a passive presence in space to the active control of orbital infrastructure. It is no longer just about the station and its modules, but about creating a distributed network of assets capable of operating as a single integrated system. This includes additional docking nodes, autonomous power platforms, and independent orbital units capable of functioning separately from the main station. According to insiders, a concept involving orbital energy hubs is under discussion. These facilities would be able to collect solar energy and distribute it to other space assets. This appears to be preparation for the creation of a fully autonomous orbital infrastructure that would no longer depend on constant launches from Earth. If such a scenario becomes reality, it would represent a genuine technological breakthrough. Another area attracting significant attention is space-based manufacturing. Chinese research centers are already conducting experiments involving crystal growth, the production of ultra-pure materials, and the testing of advanced alloys in microgravity. According to analysts, however, this is only the beginning. Over time, the orbital base could evolve into a fully operational industrial platform. Imagine factories operating in space, producing components for satellites, telescopes, and even interplanetary spacecraft. Under microgravity conditions, it becomes possible to manufacture materials that simply cannot be produced on Earth. This opens the door to entirely new technologies capable of transforming industries ranging from electronics to medicine. And this is where another crucial point emerges. If China becomes the first nation to establish large-scale manufacturing in space, it would gain not only a technological advantage, but also a significant economic one. This could lead to the emergence of an entirely new market, the space industrial economy, in which critical resources and advanced technologies are concentrated in the hands of a single dominant player. At the same time, China continues to expand its efforts in automation. It is investing heavily in robotic systems capable of performing complex orbital operations without human intervention. These include assembling structures, repairing equipment, and even managing cargo logistics in space. Some sources claim that in the future, much of the orbital base could operate almost entirely autonomously. Human crews would primarily supervise operations and conduct scientific research, while autonomous systems would handle most routine activities. Such an approach would dramatically reduce operating costs while making the entire project far more scalable. Against the backdrop of these developments, security is becoming increasingly important. The more assets that occupy Earth's orbit, the greater the risks of collisions, technical failures, and even deliberate interference. China is actively addressing these challenges as well. According to Western intelligence assessments, China is testing advanced orbital monitoring and traffic management systems. These include tracking space objects, predicting orbital trajectories, and developing technologies to prevent collisions. However, experts point out that such capabilities are not limited to defensive purposes alone. In practice, this amounts to building a system capable of managing the movement of objects in orbit. If one nation acquires these capabilities before everyone else, it gains a substantial strategic advantage. This explains why some analysts have begun using the term orbital capture. This does not imply a literal seizure of space, but rather the gradual establishment of strategic positions, the construction of essential infrastructure, and the creation of a system upon which other participants increasingly depend. Looking at the broader picture, it becomes evident that China is following a carefully phased strategy. First comes the core space station, then expansion. Next comes a transportation network. After that come manufacturing, automation, and energy infrastructure. And ultimately, the goal is to create a complete ecosystem capable of operating independently. It is important to understand that projects of this scale are not completed in a single year. They represent strategies spanning decades. Yet it is precisely now that the foundations are being laid that will determine who becomes the dominant space power by the middle of the 21st century. Some experts are already drawing parallels with the age of exploration. Back then, the nations that first established themselves in newly discovered territories gained advantages that lasted for centuries. Today, space is gradually assuming the role once played by the world's oceans. In this context, China's orbital base is no longer simply a scientific project. It has become a symbol of a new phase of global competition, where the stakes are far higher than they appear at first glance. Because this is no longer just about technology. It is about a future in which access to space will determine economic and political influence. If China succeeds in carrying out its plans, the coming decades may witness the center of global space activity shifting in its direction. At that point, the question will no longer be who will go to space, but rather who controls the path to it.